Hi guys, I'm Jay. Today is my LeetCode review vlog on 274th problem, H index. We are given an array of integers, citations, where citations of I is the number of citations a researcher received for their ith paper. We have to return the researcher's H index. According to the definition of H index on Wikipedia, the H index is defined as the maximum value of H such that the given researcher has published at least H papers that has each been cited as at least H times. So I got a hint from this problem is the H papers and the H and their citation times. So the citation times must be bigger or equal to the papers numbers, which is H. And we got several examples. For the first example is 3, as the researcher have 5 papers, but 3 of them has more than 3 citations, so the output is 3. Then let's start it with our code. So for the first approach, which is very straightforward, we could call it the sorting approach. It is a very straightforward way to solve the problem. And the detail is we can sort these citations array in descending or ascending order, and then we can easily compare the citations count of each paper with its rank in the sorted list, because it represents this represents the number of papers with equal or more citations. So let's start with our code right now. Sorting approach. In the first step, we could have to use the arrays.sort to sort array, or to sort the citations array. This is the first step. And the second step is we have to iterate through the array to find the H index. We could have a for loop and a iteration pointer, and the condition to keep iterating is I is less than citations array dot length, and increment I after each iteration. And inside the for loop, the first step is we can calculate the possible H with citations dot length and minus I, as we started from the 0th position to the last position. Then we have to check if the possible H is feasible. If citations of I is equal to or bigger than H, which means it meets the condition this problem asks for, and also means we found the feasible, we found the correct H. And out of the for loop, which means we didn't found the appropriate edge within this loop. And let's submit it. to check the answer. Also, we can have more, oops, there's something wrong. Oh, it should be possible edge. We can go deeper into this code. First, we use array.sort to sort the array. Then we have a for loop to iterate through the array. And inside it, we calculate edge for the current position, which is citations.length minus I. This is the current possible edge in the current position. Then we have an edge. It is the length of the array minus the current index, which effectively counts how many elements are greater than or equal to the count citation, which means the conditions the problem asks for at least 8 papers that have each been cited at least 8 times. So, if we meet the condition, we can return the possible edge. And this is the bigger one, because our possible edge, it is always getting down through the for loop. And this is the sorting approach. Then we can analyze the time complexity and the space complexity. So for the time complexity, we sort in the array, and which is a quick sort algorithm. So it is big O of n times log n, as this is the time complexity for a quick sort. On the other hand, we have another for loop which takes big O of n, but the sorting algorithm dominates the main time complexity. So the final time complexity is big O of n times log n, and for the space complexity is big O of 1, as we only use a possible edge variable to store the current edge in the current position. This is the first approach, which is feasible but not as good as the best. So we could come up with a better solution, and it is called a sorting. We could call it a counting sort algorithm, and this is the counting sort algorithm. And the intuition is we can also employ a different strategy that avoids sorting the array with the arrays.sort. So the main idea is we can use a counting sort mechanism, which is particularly effective because the range of the possible edge, which means the possible citation counts, is limited to the length of the citations array. So the possible value of H index is from 0 to n. So is total n plus 1 possible answer. This is a very variable hint. So our approach is based on creating a histogram of citations where each being represents the number of papers with a certain citation count. Then we'll aggregate the counts from the end of the histogram to find the H index. And let's get started with our code here. First, we can calculate the length of the citation step length. Then we could create an extra array to help solve the problem. And there's one thing that we should know is the length of the new array. It is n plus 1, as there is n plus 1 possible answer from 0 to n. Is n plus 1. And the counts array is used for citation counts. Let's say counts of 2 equals 3. It is 3. Fruits of 2's value is 3, which means there are 4 papers that all have the same 2 citations. So this is the histogram that we want for. The position stands for the number of citations, and the index or the position stands for the number of citations, and the value stands for numbers of paper. This is the usage of this citation counts array. Then this is our first step. We could use a for loop to collect all the citations from the paper. We can use an enhanced for loop. Int citation element. And we got the citation element from citations array. Then we could calculate, we could update counts array with math.minimum of citation and n. Then we can increment the value at counts of math.min of citation and n. This is for count citations within range 0 to n. And here's a math.minimum method here. The reason is, if the citation is bigger than the n, we have to take n. The reason is, as I mentioned before, we can have at most 8 papers, but each paper can have as big as possible big possible citations than the age. So if the citation is bigger than n, we have to take n. And this is the first step. And comes to the second step is, we can use a variable. We can call it papers with 0. It is for counting the papers which meets the age index condition. And we can have a second for loop and we could have an I pointer when it shouldn't be started with n. We have to traverse the array in a descending orientation, descending order. If I is bigger than or equals to 0, and then we decrement I. And inside the second for loop, the first step is we have to accumulate the feasible papers, which is plus equals counts of I. As we traverse from the descending order, so the papers in the behind position has the bigger opportunity to meet the age index condition. This is the first step, which is used for accumulate papers with citation. And the next step is we have to check if papers is bigger than or equals to I. If so, we have to return I. If the condition meets, which means we found the edition. And there's another situation is we can't find it, so we have to return 0, which is the default case. And let's check with our code here. Oops, there's something wrong. N plus I. Yes, I got it wrong. I have to correct it. Citations. Then we can go deeper with our code here. So the max bin is not pliable. Yes, this is we have to use for the element, not the array. We can go deeper with the code we are using. So we have the first step is we have to counting citations, which is the selected code snippet. We create an extra array to collect all the we have to count all the citations for each paper. And for the second step is we have to iterate backwards. We iterate from the number of papers as we iterate through the count array. Once the accumulated papers count becomes greater than or equal to the count citations, which means we found the H index. And let's analyze the time complexity and the space complexity for the second approach, counting sort algorithm. And first, the time complexity, it is big O of 1, as we only iterate backwards through the count array, which takes big O of n time. So the time complexity is big O of n. And the space complexity, it is big O of n, 2, as we create an extra array counts to help and solve the problem. And thank you guys for watching. This is the code review vlog for this problem. And you can also check for the detailed notes on my GitHub repository here. And thank you guys for watching. See you next time.